This will be for the con exercise, interpret time in exponential models. Caswell started studying how the number of branches on his tree grows over time, the relationship between the time t in years since he started studying, and the number of its branches, n of t, is modeled by the following function. Complete the following sentence. Every blank years, the number of branches increases by an additional 64%. So, first off, in order to increase something by an additional 64%, you want to multiply that number by 100%. You start with 100% of something, and you want to increase or add 64%. So you want to multiply by 164%. Now, in terms of a decimal, if you move the decimal over 2 places, that just equals 1.64. So if you multiply a number by 1.64, it will increase it by 64%. And that's exactly what they did here. Okay, they took the initial value, 15. This will always be the initial value, but it should say it in... No, it actually doesn't. Okay, it's not in the write-up. But just for your information, this function is in the form of y equals a times b to the power of x. All right, and this is the initial value right here. But in this case, it's kind of irrelevant what the exact value is. All we need to know is that wherever we started, it increases by, it gets multiplied by 1.64 each time. So it increases by 64% each time. Okay, now they said t is the time in years. And they want to know every blank years that it increases by 64%. So in order to increase this by 64%, we multiply it by 1.64. Okay, so just to increase it once by 64%, it's going to be 15 times 1.64. Okay, and you can say this is to the first power if you like. But we have this exponent here. We need this exponent to be to the first power. This way it increases by 64% one time. So t over 3.4 just equals 1, in which case t is going to equal 3.4. And they said t is in years, so the 3.4 is in years. So basically, whatever made this exponent 1 is the answer. So just click in the box and type 3.4. The relationship between the elapsed time t in seconds and the number of bacteria n of t in the Petri dish is modeled by the following function. Okay, complete the following sentence. The bacteria culture loses 5/8 of its size every blank seconds. All right, let's see. Now, it said t is the time in seconds. All right. And if you multiply something by 3/8, all right, if you do times 3/8, what happens is you lose 5/8 of that value. Okay, and the reason is because 1 minus 3/8, and this would just be 8 over 8 minus 3/8 is 5/8. All right, so if you multiply by 3/8, you lose 5/8. So in order to lose 5/8, you just multiply by 3/8 once. So in other words, we want to have this equal 4,900 times 3/8. Okay, and that would make us lose 5/8. So times 3/8, you can say times 3/8 to the first power. So in other words, this exponent has to equal 1. So t over 7 equals 1. And of course, t is just 7. Okay, 7 over 7 would make it 1. So if this t were a 7, you'd multiply it by 3/8, and it loses 5/8 of the value. So it's going to be every 7 seconds that occurs. All right, just to explain it a little further, when t is 14, that's going to be 14 over 7, which is 2. So in that case, it would be 4,900 times 3/8 squared, or times 3/8. Okay, this is 3/8 squared. So every time the t goes up by 7, you got another 3/8 being multiplied. And every time you multiply by 3/8, you lose 5/8 from the value. The relationship between the elapsed time t in months since Arthur sent the letter and the number of people P of t who received the email is modeled by the following function. Okay, Arthur sending a chain letter to his friends, and then they forward it to more friends. The number of people who receive the email grows by a factor of 5 every blank months. Okay, factor of 5, you can replace the word factor with multiple. So you can think of a multiple of 5. Okay, same thing. Now they want to know how many months it takes to get multiplied by 5 each time. Well, it said in the problem that t is the number of months. Okay, so we have 12. And if we want to increase that by a factor or multiple of 5, we multiply it times 5. Okay, instead of 5, you can say 5 to the first power. That's the same thing. So this exponent just gets equated to the number 1. So t over 3.6 is going to equal 1, in which case t is just 3.6. Right, the same number over itself is just going to be 1. And they said t is in months. So every time this goes up by 3.6, it gets multiplied by 5 every 3.6 months. So right in the box, 3.6.